In a control system, the signals is actually information. This information can be represented in three forms. Number one in analog form, number two in binary form, number three in digital form. If you take a voltage against time sheet, whereby the voltage is the information in analog form is actually a continuous value, and this value is infinite. If the voltage in the dimmer system increases, the brightness will also increases. If the voltage in the dimmer system decreases, the brightness will also decreases. The value of voltage and the light intensity of the bulb are infinite. In a binary form, the information can be seen in the chart is in discrete value. This value can only be in two values. For example, it can be either 0 volt or 24 volt. If we give 0 volt to a relay, the relay will not energize. If we give 24 volt to the relay will be energized. In a digital form, the information is also a discrete value, but the value can be finite or can be in multiple value. This type of information can be handled by PLC or either microcontroller. The function in PLC such as timer, counter, arithmetic function are dealt in digital form. In this course, we will focus in binary and digital form of information. Signals in a controller are processed based on a control program. This control program can be classified into two. One is logic control, the other one is sequence control. Logic control usually it evaluates different states in the system for protection or for safety purposes. For example, if the gear in the car is in D gear, the car cannot be started. If the hand is not detected, the water cannot flow. This is to conserve water. If the sensor detect human passing through, it will open. For sequence control, there are two orientation. One process oriented, the other one is time oriented. Sequence control work in step by step. For one step to be activated, it must wait for the TC to be true. The TC is referred to as the transition condition. For process-oriented, the TC always refers to the process or to the sensors in the processes. For example, like this vending machine, there are many sensors for process such as pick and place, moving process, coin retrieval process. Another example in this ice cream machine, where there's a sensor to locate where to stop, and it's also control various speed. For time orientation, the TC is depending on time. For example, the traffic light. But most of the time in automation in mechatronics, they are combination of process orientation and also time orientation. In this chapter, we will cover both logic control and sequence control program. Now, when I say programmable controllers, they are not necessarily meant for PLC only. There are a lot of other programmable controllers available in the market. Is this a programmable controllers? No, it's not. It's just a remote control. The controllers is in the TV. So we take this out. The most popular programmable controllers available in the market is Arduino. Hobbyists use them to create a small automation project, such as its mobile robot. But for industry, for complex automation in industry, they definitely prefer PLC. Both of them has a microcontroller embedded in them. Okay, this microcontroller has the same concept. There is the same component such as microprocessor in the CPU, RAM, program memory, ADC, and also DAC. They are both also similar in sizes, but they are definitely different in the durability. A more advanced version of programmable controllers available, such as MATLAB and also LabVIEW. In this course, we only focus on PLC. So PLC is actually a digital electronic device. It has a programmable memory where we can program specific functions such as logic, sequence, timing, counting, arithmetic to control machine and other processes. PLC come with a lot of manufacturers. These are some of them that I can list on. But every PLC, they are using the same programming language, the same concept of writing the program, but they are just different in the symbol and some syntax. There are various physical shape of PLC from different manufacturers, Omron, Siemens, Mitsubishi. In this course, we'll be using Siemens PLC. So I will briefly explain to you the list of product available for Siemens PLC. Siemens has this small PLC for small compact automation or micro automation, Logo and S7200. And for bigger automation, for better performance, programming with high level language, there are another set of PLC, S7300 and also S7400. But in the current market, S7200 is already obsolete, replaced with S71200. Same goes with S7300, also obsolete, replaced with S71500. Now, these industries such as power industry, renewable energy, automotive, oil and gas, railway system, food and beverages, they all prefer PLC to be used in controlling their automation because of the durability, as I said before. The specific reason is in this list. The PLC is designed for extended temperature ranges. It can withstand dirty and dusty condition. It can resist high vibration and impact. Same like Arduino just now, it comes in small physical size. It is easy and also faster to make changes when they want to upgrade the automation. Easily documented and also cost effective in the long run.